Here's an application of using centroids of lines and centroids of areas. It's called the Theorem of Pappus. We'll use this theorem to generate surface areas and volumes of lines and shapes that are rotated around an axis. And so I've taken the song, "The Wheels on the Bus Go Round and Round," and I've changed it to "The lines and areas of the bus go round and round." And this all involves circles. And so if you draw a circle, the perimeter of that circle going around is 2 pi r. So just remember that. The perimeter of a circle is 2 pi r. So here's the concept. If you have a line that has a length and you spin it around an axis, and if you multiply it by 2 pi r, that will give the area, because it's a length times a distance is an area. Similarly, if you take an area and you multiply it by a perimeter, 2 pi r, you get a volume, because an area times a length is a volume. The question becomes, what do you use for the radius for this 2 pi r? Well, the answer is, you take as the radius the distance from the axis to the centroid of the line or the centroid of the area. For example, if you take the length of this line and multiply it by 2 pi r, where r is this distance from the axis to the centroid of that line, that will give you the surface area of that cone. If you took the length of this line, h, and you multiplied it by 2 pi r, the centroid to that will give you the surface area of that cylinder. And finally, if you took the length of this half circle and you multiplied it by 2 pi r, where the distance r was that, not the whole radius, but the distance to the centroid of that arc, which is 2r of a pi, that length times that radius times 2 pi will then give you the surface area of that sphere. Similarly, if you took the area of that triangle and you multiplied it by 2 pi r, where r is now the distance to the centroid of the triangle, that would give you the volume of that cone. You take this rectangle, the area of that rectangle, multiply it by 2 pi r, where r is the distance from the axis to the centroid of that rectangle. That will give you the volume of that cylinder. And finally, if you took the area of that half circle and multiplied it by 2 pi r, where r is this distance, the distance to the centroid of that half circle area, you'll get the volume of a sphere.